right? So this talk is going to be more on the application side of big data. I'm Murtaza, I'm the Director of Engineering at TubeMogul. I manage like all the real-time bidding teams at TubeMogul. And then I'm co-presenting with John, who's actually our Chief Scientist. So he's going to talk more about the actual application in terms of machine learning and how do we leverage all of these technologies. So the outline of the talk is we're going to do a quick introduction of what TubeMogul does and how do we fit in the entire ecosystem. And I'll talk a little bit about kind of how a video ad works, because our focus on TubeMogul, although we do all kinds of advertising, video is dominantly our focus. And then I'll touch upon the RTP architecture and the events architecture. And I'll hand it over to John, who's going to talk about how do we convert these events to insights, and then how do we convert them to actionable aspects on the platform. So this is obviously a really busy ad tech landscape, and you can imagine, right, there are multiple players in this ecosystem, right from supply side partners to demand side platforms to data management platforms. So it's a very, very crowded ecosystem, as you can imagine, and obviously where we fit in is on the demand side platform side of things. So TubeMogul is actually a DSP. It is a little more than what we do on a DSP, but it's easy to explain when we consider ourselves a DSP, demand side platform. So, where do we fit in, right, in terms of this entire advertising ecosystem? On the left-hand side, you have the advertisers, which we represent, or the brands. On the extreme right, you see the publishers. So an example of a publisher could be like YouTube, or a website like CNN.com. And then there are various ways of bridging the gaps between the demand side of the platform and the supply side of the platform. So the various means are you could do a direct connect from the advertiser to the publisher. That's one way. That's one way of doing the business. There are various ad networks in this industry, like the Brightcrow and Tremors of the world. There are exchanges where the auction actually happens. So Google is a good example. You have Right Media, which is the Yahoo, DoubleClick, Spot Exchange, Adapt TV. And then on the demand side platform, obviously that's where we fit in as TubeMogul, right? So what we do is we represent the brands, and then we help them monetize, or we help them figure out what is the best inventory which we can target for them and serve their ads. So that's kind of our job as a demand side platform. Obviously, I'm kind of oversimplifying the entire ecosystem here, but that's kind of where we fit in on the DSP side. And then the way we work on the TubeMogul is that we integrate with practically all of the supply side partners of the SSPs. So we don't have to directly deal with the publishers, but we can directly integrate with the SSP, and the entire fire hose of inventory or impressions are then seen by TubeMogul. So that's kind of where we fit in. If you're not very familiar with the ad tech ecosystem, feel free to ask me any questions around this. But the goal here is that from a TubeMogul perspective, we want to get access to the best inventory, make it available for advertisers so that they can target and eventually bid on these things. And then we'll talk a little bit about the flow as well. So, from a scale perspective, right, what are we talking about from a TubeMogul perspective? So, let alone, so now obviously we're a public company. We went public in 2014, but just in terms of the overall scale where we are at today, we served 12.6 trillion ad auctions in 2015. So that's the auctions we saw. On a daily basis, we see roughly about 55 to 60 billion auctions. And obviously, the auctions is one thing, right? But as soon as an auction comes in, we would decide whether we're going to bid on this particular opportunity or not. So that's the bidding activity. So, and then after that, we actually serve the particular ad, which then generates an impression. So that's what we call, our terminology, a win event. So there is obviously another business which TubeMogul is also kind of being one of the market leaders there, is the programmatic TV solution. So we serve 3 billion ad impressions on linear TV, and that's picking up. That market is kind of really picking up from a TV advertising perspective as well. So our goal is obviously not to have one single channel. We can serve on various different channels, TV being one of them as well. The one important part about our platform is the SLA and the latency, right? So when you serve an ad, we have very, very strict SLAs. So we cannot afford to go beyond like 50 milliseconds. So the entire platform, the amount of time the entire platform takes to actually decide to bid on an opportunity and bid, is less than 50 milliseconds. In the entire round trip, including the network latencies and everything involved, we have to kind of have the bid responses under 80 milliseconds. A lot of our partners kind of cut us off at like 100. So anything beyond that, we won't be able to serve an app. So the way we have to think about the platform and the way we have designed the platform, performance is one of the key metrics which we want to track, and the availability of the platform as well. So obviously, if you're serving all of this data, there is a big aspect of you collecting all of this data as well, right? And that's where the events come in. How do we collect, we store, and then how we gather this data, and then what do we do with this data once we collect it? So obviously we serve 5 petabytes of monthly video traffic. So we have humongous amounts of data which flows through our system. We store the data, we process the data, we crunch it, and then we obviously have to create models and then actionable insights out of it. So that's the other aspect of it. So I'm just going to very briefly talk about what a life of a video ad looks like. If some of you guys are familiar with the ad tech ecosystem, this might just be kind of repeat there, but just at a very high level, right? Like if you're visiting youtube.com, which is and that's kind of a video player, and as a user, there is an opportunity created, right? That's what we call as the ad slot in the advertising terminology. That ad slot then goes to the publisher or the ad server. So in this case, let's assume it's Google, right? So it goes to the Google ad server or publisher. And then Google then decides that, hey, I'm not going to directly serve this particular auction request. What I'm going to do is that I'm going to open this up on the exchange so that multiple partners can actually bid on this opportunity, right? So this is like a trading desk scenario now. So Google then opens up the ad slot on the exchange for an auction to happen. And TubeMogul is a DSP, right? Like I said, it's a demand-side platform. So we are actually integrated with the Google Exchange. So any auction happening on the Google Exchange, we get an opportunity to actually bid on it. So that's what happens on step number 3. A bid request actually gets sent from the Google Ad Exchange to our bidders. And obviously, I've oversimplified the picture here with bidders, but this is obviously a very fairly distributed architecture with the various different subcomponents on the bidder side. But at a very high level, what we have is bidders. And then let's assume that it goes through the entire bid flow, which we have on our end. We do user targeting and a lot of other targeting criteria, which gets applied on the bid request. And then let's assume that we basically have all of the demand booked on our system, which is our campaigns or ads, and we decide to actually bid on this particular opportunity. So what happens is that we respond back with a bid response with a price in it. And then a real auction happens on the Google Ads, because TubeMogul is not the only partner, right, which is integrating here. There could be multiple various other DSPs which are connected in this ecosystem who will decide to bid on this opportunity. And let's assume that we win the particular auction request or the particular auction here. What happens then is that a winning tag gets sent back to the Google Ad server, and then that information is relayed back to the ad player or the video player. And now the next life cycle starts, right? So the bidding activity is now completed. Now the next activity in line is that how do you serve an ad? So another call actually gets made to our ecosystem, which is our ad serving ecosystem or our ad serving platform. And then based on that ad request, an ad response is generated. And once the ad response goes to the ad player, now you have to fetch the assets. So now you have to actually fetch the video which needs to be played before the actual content on the video starts. So when you visit youtube.com and you see those, a lot of the ads, sometimes the skippable or non-skippable ads, that actually gets fetched in most cases from the CDN and then gets played in the player. So this is kind of the entire ecosystem. Now you can imagine, right, while you are looking at a video, roughly this all of these things happen in less than like 250 milliseconds overall, because there are a lot of handoffs happening from the ad publisher to the exchange, to the DSP, the response back, the ad serving. So anywhere, there's a glitch in this ecosystem, end of the day, an ad is not served, opportunity is lost. So in a lot of cases, publishers then have backups, right? They have what they have is house ads. So if for some reason we can't serve an ad here, even after winning a bid, obviously the publisher is going to serve a house ad, which is like a backup ad, which they put in the system. So at a very high level, this is kind of the life of a video ad. I want to jump to more on the architecture side of things, on the technical side of things, on how, and this is again, like I've tried to go one level deeper based on what we have, but again, this this is kind of breaking down the ecosystem in various different mechanisms. So what we have is the browser and the SSP, and what we have is the bidding layer. So we have built a bidding layer which is obviously homegrown, and that's kind of a secret sauce on the platform side of things. And obviously it's a very, very low latency platform. So we have aspects around caching, very efficient caching mechanisms. We obviously want to make sure from a bidder perspective, we don't make a lot of off-box calls. So once a bid request comes in, we want to serve it from the bidder itself, right? So indexing becomes very critical, caching becomes very critical. We have to have very optimized networks internally, and obviously we have to do a lot of algorithmic things as well in the bidder, right? You have to target, you have to do frequency capping. So all of these things happen on the bidder layer. And then obviously the bidder is the layer which actually also integrates directly with the SSP or the supply side partner. The next one up is the ad serving layer, right? So this is where you have the browser directly calling our ad server, or in a lot of cases the ad player if it's a video ad. So there are a lot of third-party interactions happening with the ad server. So that's a second part of our ecosystem, right? So how do you serve an ad, and what is the most efficient pipeline look on the ad serving side? So that's the ad serving flow. So you have the bidding flow, you have the ad serving flow. Now, obviously, the one important part here is that we'll talk about this a little bit in the event side of things. Is this entire architecture, there are tons of events being generated. There is a bid event being generated. There is what we call as a non-bid, which I'll talk about a little more. There is an ad impression. There are various pixels being fired. When you do an ad, if you actually look at your browser and if you dig deep in how the network looks like and the amount of calls, you'd be surprised. There are like tons and tons of calls which are being made to external partners, right? A lot of for cookie tracking, pixel tracking, DMPs, retargeting. There are tons of information, and the only way they can get information after that call is by firing a pixel. So there's a lot of data collection happening behind the scenes, which obviously I've not put in this picture, but there are a lot of event collection all over the platform. And that's what we have this, the ad events or the stats, right? So as soon as the player starts sending signals that, hey, now the ad is playing on the player, a lot of events or pixels being sent, or quartile completion pixels, what we call. And the reason we do this is because when you're engaged on the video player, we also want to know that how long were you engaged with it. The first time the ad rolls in the player, that's when an impression pixel gets fired. But then as the video progresses, there is a 25th percentile, a 50th percentile, a 75th percentile. All of those pixels are being fired on that ecosystem, so that we figure out like how engaged were you with the ad, and then engagement metrics and other things which John's going to talk about. Those are all insights which we can derive out of it. And then the last half of this is that the user targeting piece of this is very, very critical for us. So we have to understand who the user coming in is. So we have to figure out what segment the user belongs in, so that we can give you the most targeted ad or the experience. And that's what happens in the user cookie and the segment collection. So we collect all of this data, the user data, all of that gets ingested into our user database. And then next time when you come in, if we can recognize you as a user, we can better target, give you a more targeted experience on the ad. So that's where a lot of the aspects around machine learning, optimization, segment building come in. So that's the last half of that ecosystem. So I'll talk about the events, right? So we talked about the auctions or the bids. Now, a very critical part of this ecosystem is the non-bids. Now, you might imagine, like, why is non-bids so critical? So non-bids is the fact that, we decided to not bid on a particular opportunity. And non-bids are critical because we would like to figure out or have some insights around, like, why did we drop this particular opportunity, or why did we not bid on it? It could be that the user was not in segment. It could be that, hey, the ad or the user was actually coming from another geolocation, and the advertiser wanted to target a specific zip code, and the user coming in did not belong to that zip code. But there are a lot of insights which you can gather. So you can imagine, right, if there are 55 billion options coming in on a daily basis, you can imagine the kind of the fan out of the number of events we are collecting behind the scenes. So it's very, very important for us to make sure we have the right event architecture, and more importantly, how do we store the data. So that's what the bids and the non-bids is, and the bid events is a little more straightforward because as soon as we win an auction and we have to serve an ad, we generate what we call as a win pixel or a win event, and that's the impression pixel. So that's, in terms of scale, that's negligible, right? Because obviously on 55 billion auctions, we do not win all the auctions. So we win a percentage of that, and that's where the win events get generated. The other piece I want to talk about is like, we use efficient columnar format storage. We use ORC. We experimented with quite a bit, but I think ORC is the one which had the best efficiency, and downstream we'll also talk about how that kind of sped up some of the Hive queries which we have. The data pipeline. So with this kind of events coming in our system, we have to build a very efficient data pipeline. So the next slide I'll talk about a little bit on the architecture of the data pipeline. And then a big challenge we have is bad data, right? So I'm sure, for the folks who have been operating large-scale ETL pipelines, having bad data in the system is a known problem. So how do we enforce and how do we make sure that we can cleanse data as it goes to the system? And there are caveats to this, right? You can put all your rules at the very beginning of the ecosystem and say, I'm going to filter all kind of junk data which is going in my system. But then a lot of times what happens is that you also want to detect fraudulent activity downstream. So if you just do a quick filter on all the data which does not kind of fit in that particular in our ecosystem based on various different parameters, you're actually not going to be able to detect bot traffic or traffic which we have not interpreted correctly. So it's very important to apply these techniques at the right aspect of the ETL pipeline. And so that's something we'll briefly talk about. Scaling challenges, right? Now with this event like this, so obviously TubeMogul, we are growing our business. So if we double and triple the integrations on our end, if we integrate with many more SSPs, we have taken on display traffic, we need to scale this entire pipeline. So today if you're doing 55 billion, and next year if we decide to double that particular volume, our system needs to scale. So that's the scaling challenges, and obviously multiple downstream consumers. And I'll talk a little bit about this, that when we're working from an advertising organization perspective, the data is valuable. Obviously there are data scientists, they are valuable to our BI team, they are valuable to our support and app engineering team, they are valuable to engineering. So there are various departments who are interested in different parts of the data. So obviously we don't want to create silos on the data and have the data stored in 10 different locations. But considering the big data landscape, there are efficient use cases which get done on what we call as NoSQL databases. There are efficient use cases where you can run Hive queries or you can run Presto. And there are other cases where a relational database makes sense if you're too concerned about asset properties or other aspects. So a lot of these things are very real for us, and we're dealing with those challenges. So this is kind of a very high level, again, an events architecture which we follow. We have the bidder and the ad event. And the one thing we quickly realized is that we introduced Kafka early on in our data pipeline. So what we do is all of this data is actually produced by the bidder and the ad event and the ad server. Obviously, we have a set of Kafka brokers where all this information is stored, and we have a retention of 48 hours in most cases. And then the aspect around this which is important is that there is multiple consumers, like I said, right? And each consumer wants to pull the data at different rates. So a solution where you have things like Flume, where you have push all the way through, where you push your data to the Hadoop ecosystem, that doesn't work too well for us. So we have to come up with a push-pull mechanism where the data gets pushed to the Kafka brokers, and the consumers are then pulling the data. And the consumers are pulling the data at their own data rate. So if we have a consumer for edge base, I need my real-time segmentation workflow, or I need to figure out why I'm not bidding. And that's all real-time information which needs to get updated on the edge base side of things. Now, on the flip side, data in Hive, we do hourly rollups there. So I can afford certain amount of latency there. Even then, if I miss an event, we need to do the right kind of bucketing there. But that's not as real-time as the edge-based use case. And same thing with vertical. So based on these different rates and the fact that we have to collect all this data, we use S3 as our storage mechanism, we have to come up with all these different consumers. So the way these consumers run is that they run as Swift workflows on Amazon. And once these workflows run, we can track them to figure out what stage they are in. Every workflow has a validation phase built into it. And every workflow can basically, we maintain all these offsets in Zookeeper. So if a certain part of the workflow fails, we exactly know, what part of the batch we have to reprocess. And then we reprocess the batch, and then obviously the data goes downstream. So this is a critical aspect of our events architecture, right? And again, this is a little bit of oversimplification here, but if you have any questions, let me know. But I think the goal behind this is that we obviously don't want to lose data. We want to have the best validation possible. We don't want to throw garbage data downstream, but you want to have the right kind of validation at the right stage. And then we store this data downstream. Yes, please.
Do you have any idempotency requirements in the whole system?
So we do, I think, so the way these consumers work is that, we have these various checksums which we create on the way as well as we have option ID. So if we see a repetition on it downstream, the consumers try to dedupe in that window. If it goes outside of that window, then we let it go downstream and let the ETL handle it. So there are various levels of dedupe. They are built in the consumer if it happens in the window of the hour or the 15-minute chunk. If it doesn't, if we don't catch it then, if the event is delayed for some reason, because like we deal with a lot of mobile traffic, and in a lot of cases we see that even though we serve an ad on a mobile device, the actual win pixel comes like 1 hour later, because that's the time they decided to actually process all the events. So then we see a sudden burst of events coming to our system. So we also have to handle for kind of peaks and bursts into our system. So then we have the ETL pipeline which does a lot of the deduping. So that's how we kind of handle this. And obviously the key takeaways I would say from an events architecture perspective is simplification and unification, right? And as we evolve our architecture, there are tendencies that you could build silos on your platform. You could have like 6 different teams working on different ETL pipelines, different technologies, and we all are very familiar with like there are tons of technologies coming up in the Hadoop ecosystem, right? And there's always, you have to use the right set of tools to solve the right set of use case. Now that could mean that you might get inundated with technologies, but in a lot of cases, what we have seen is like, we start with a technology, we try to solve a use case, and a lot of cases we want to simplify it. So we don't want to have like 20 different technologies sitting in our platform and then complicating the entire use case. So every time we do a project, we try and make sure that we can simplify and unify the workflows so that the data discrepancies, the aspects around making data available to the downstream consumers happens more realistically. And then the focus on data validation at each step, right? So there is, the way I think we have thought about this is, and the way we have done it is, the data validation happens at every stage of the process. There is no one magic bullet where you have all your data processing or data validation happening at one stage on the start of the ETL pipeline, and then everything downstream kind of, takes care of it. At every step of the ETL or every step of the event processing pipeline, you want to make sure your data validation is put in. And the best way to do this is that you actually run your workflow and you validate whether it's checksums, the number of events, you can do it within a window, you can figure out like if there is any kind of activity which you don't recognize like a source or any kind of pattern which you can detect. And you want to make sure that data validation detects it at that stage, right? And then recovery. So like I said, if one part of the ETL pipeline fails or one step of the ETL pipeline fails, you don't want to, kind of fail the entire workflow. You just want to reprocess that one batch. So that's important from a recovery perspective. And then the one thing is leveraging the messaging system. So we have this Kafka pipeline, but the important thing is that even the workflows can leverage the Kafka pipeline. So let's say a batch is completed on Kafka or a batch is completed by ETL. The actual process or the step can actually put a message in Kafka pipeline to say, hey, this batch is now ready to be processed. The downstream consumer can then kind of listen for those messages and say, oh, this particular batch is completed, let me go reprocess that data. So instead of like saying, I'm going to do a poll mechanism to see my hourly partition has showed up and then reprocess, or kind of a push thing where the producer is then responsible for doing all of these things, you completely isolate the two workflows. Whenever the producer is ready and process the entire data, then it pushes the event on the Kafka pipeline. The consumer is listening for events. Let's say a data completion event. It sees that data completion event happened for 27 April at 9 p.m. My batch of data is ready to be processed. And it can start processing. So it's very important to kind of clean up those workflows and make sure that the completion of all of those things can be leveraged by more of like a messaging framework. And the last thing is metrics and measurement, right? So you want to measure your every step of the workflow. Obviously, you want to make sure that the SLA is maintained. So if a certain job in your pipeline is taking more than 24 hours, if the event has not shown up, you can at least detect that. You can kill the workflow and restart it and do all kinds of recovery aspects around it. So metrics and measurement around the events architecture is also very critical. So at this point, I'm going to hand it off to John, who's going to talk about more of the interesting stuff around machine learning.
Yeah, hi every time I see Murtaza talk about the amount of data we have going through the system, I'm reminded of our founder who constantly says that I never met data I didn't like because I never delete stuff from S3. So they collect a lot of data from the system, and I actually make it more. One of the big things we do is this data obviously coming through is a rich source of information that we utilize for all of our downstream processes, which are typically oriented towards targeting the appropriate opportunity for users, or users that essentially fulfill the desires of our brand to target them, whether it be demographics or behavior and so forth. So audience modeling is a big use that we have of that data. And I think about big data in general is a constantly evolving process. No matter where we are in the process, we're always bursting into steam to do something new. And one of the things we try to do is try to look at the architectures out there, the new approaches, going from Hive to Presto to Palo we've looked at, all these things. Any given time, we're trying to figure out what next can we use to really handle this gigantic amount of data. At the front end of the system, we're talking about throughputs of milliseconds and so forth. At the back end, when we're looking at this data daily, it's several orders of magnitude different in terms of the time that I have for SLA. But the same token, I have to churn through, 5 years ago it was 500 million, and then it was 2, and then it was 10, now we're 55. Any given time, we're trying to figure out how can I churn through that data, take it from this transactional data, which is really ad call comes in and we have users, sites, and so forth, and change that to be a characterization that we can use for users that is temporal. So over a month, 3-month period, can we see what specific cookies are doing relative to our ability to utilize that information to discern whether they're male 18 to 24, or whether they have a predilection for buying goods at a certain site and so forth. Part of our job is actually unifying these sources of data. So the transactional stream is one source of data, but that's just information. That's features on a user, features on sites that tell us something about them. But what we really have to do is take that, the data where we're tracking and seeing what goes on in an ad session and understanding as a dependent variable what users are clicking, what users are doing, what behavior that they're doing that's interesting to us relative to our desire to pursue them. Because if somebody has demonstrated that they've never ever clicked on an ad, we're not going to pursue them. Our goal here is to get those users that will actually do something that is a surrogate measure. We don't really have, we're not direct marketing, so we don't have that wherewithal to know that you just bought a widget, which is great. We don't usually have that, so everything we have is a surrogate relative to something you do that is gauged by our different clients to be a measure of engagement. So if you click on something, they say that's pretty good. If you do what's called a conversion, that's going downstream longer in a pipeline, you're less apt to be fraudulent, they like that better. And so to whatever degree in that deep process we can do and detect users that are interesting, that's where it really comes together. And that source of data, we call our stats or analytics side, is what we have to often unify with the huge collection of this transaction data to really make sense of this arena and make predictive models of gigantic scale that will help us to predict whether a person's apt to do something or whether they have a particular predisposition and so forth. So that's a big factor here as well. There's many sources of truth, and we integrate those. One thing we do also is, when we look at these users, we see a particular cookie, and we see the sites they went to. There's verticals that are typically assessed by the publishers, so they'll give us a hint as to that page's content. So they'll say that page is related to automotive, it's related to movies, arts and entertainment, what have you. And we have all those signals to go on. They always try to give us value added, but that value added also comes at the price of more data hanging off of every user. To put it in perspective, when we look at our user characterization, the dimensions in the space over which we characterize users is usually in somewhere between 50 and 100 million, depending on what sources I tend to bring in the mix. And that's interesting in that it's what users do, but only on the sites that have ads. So we don't see a full picture. We only ever see a snapshot of some of the things the user does, and that's, of course, the sites where ads are actually deployed. Plenty of sites don't have ads. We don't know about users there. But we try to do the best we can at squeezing out information about users relative to that bank of sites that we do see. So 100 million dimensional space by 10 billion active cookies at any given time, devices, whatever it is. You see that we're looking at a pretty darn big space, and we're trying to tease that. Every day we tease models out of that will allow us to predict things at real time. The big trick here is we're making models offline that we can ideally cache that information so that at runtime there's no evaluation going on. It's a quick cache and a NoSQL database to get that information coming in. coming in. One thing we need to also do in our back end is, given that data, have it churn through and build models. So we try to rely on things like Spark and so forth to use their facility for in-memory learning and so forth. And the key thing you're trying to get out of all this is these rich insights, whether it be the models that allow us to predictively determine something that's valuable to our clients at runtime, or whether it's something that will allow us to characterize, in general terms, the prototypical users that one of our clients sees to give them the information that, oh yeah, your target audience, you thought it was this, but in fact it's this because those people that we see going and doing engagement on your ads is a different ball of wax. So we actually have to do a lot to save information that's valuable for this exploratory and visualization analysis as well. So everything we do is geared towards maintaining as much data as we can, but in as succinct a state as possible, but some of this descriptive stuff gets a little unwieldy as well. I'm going to try to trace just a high level through a couple of things that we usually do after the fact. One thing, of course, is, and we've been driving off of Hive for a long time. We've been able to parlay the different advances relative to work and initiatives that speed Hive up. We're certainly bursting at the seams in terms of that being our, slower and slower relative to our volume. We're certainly looking at and developing right now some more NoSQL-based techniques. Aerospike, what I've heard of, is a NoSQL database particularly designed for the ad industry. We're looking at using that as a means of dynamically at the actual call time, digesting that and populating data. As it is now, we're kind of looking at an expectation that the previous day's data has been churned and digested and in terms of being collected. And at that juncture, we go through the wholesale previous 24 hours, international, we kind of systematize on Eastern Standard Time as our 24-hour clock, and digest all that data relative to a couple trellises of ad calls to a digest, which is a significant reduction. And from that reduction, actually break it out into tuples that correlate users with the things they do. And then over long durations of time, month, 3 months, 6 weeks, we collect up information about users, and that becomes the basis for our model building, predictive modeling on user behavior, demographics, and so forth. And currently, that's strictly Hive, and we've done everything we can to make that fast, but it's always evolutionary, it's timing it, we always are stepping back relative to what scale we're at and trying to revisit that. So definitely, we're currently underway and getting new solutions to this problem that will drastically expedite the process we have, and that's a NoSQL, Elasticsearch will be the back end there. We're working through this now, and that's been an unbelievable, tremendous savings relative to some of the churn we do on ETL and so forth. So, but Hive has been our go-to for a long time, and so you can imagine we're in a lot of SQL and so forth to do case. One interesting foray we've had recently is in using Spark. And as everybody knows, Spark is great and fantastic, especially when you can have stuff in cluster RAM and can churn through that. So it's pretty decent for churning through models if you can get the data in RAM. One problem we were tackling that was pretty tricky, and even in Spark, although they purportedly have an MLI, something that does this, the word-to-vec modeling. Word-to-vec essentially is an NLP process by which you're trying to take words and understand the meaning of those words relative to their neighboring words and sentences. So we have a take on that leverages the users and what they do relative to unifying a relationship between, say, NBA.com and Hoops.com, because the same users probably traversing those same sites, and getting a stronger relationship, a stronger representation of users that allows us to do more unsupervised modeling, lookalike modeling, and so forth. But the interesting thing we did at Spark was to actually kind of build off of a open source project like Deep Disk and extend that further to have this thing processing tens of billions of records of users and actually about 500 billion tokens to adjust and make a strong, robust model that we then use to characterize users. The key thing being if the user has what we call item set, is that they went to this site, saw this vertical, and did this. Their representation in this space would be essentially getting the vector that represented NBA.com, the vector that represented the verticals and so forth, and additively constructing a representation of that user that falls in a space that allows us to compare all users and essentially not be in this binary space where if one user saw NBA.com and one user saw Hoops.com, in a binary space there's actually zero comparison. In this space, once we've constructed this huge robust model, we're able to compare those, and there actually is a comparison that says those two users are similar because of the high correlation between those two entities that wouldn't be captured in binary. But long story short is this is a downpour model. You can break up that process into some subsets where each of the workers in that space can digest part of the data and then update a global model relative to communication via, in this case, a system called Flask with HTTP protocol. And the cool thing was it took us a little churning, but we finally understood the RDBs. We were able to parlay Spark. So, we're up in Berkeley, and the Spark guys are close to us, so we're trying more and more to use Spark, and obviously it's coming to the fore in a lot of processes, particularly when being around makes a lot of sense. So this is one there. We're exploring other avenues. Some of our folks are using it for inventory and forecasting as well. But Spark has been a good tool for us, and particularly in this process, which was in perspective. When I first did this, I was driving just off S3 and digesting stuff on an HPC box in Amazon. And I got that model, great model, in 2 weeks. Once we did this, I got that model in 1 day. So that was a huge boost relative to digesting 10x more data as well. Yes?
What machine learning model are you guys using?
Well, this is a word-to-vec. So word-to-vec essentially is a shallow neural net relative to the number of inputs being proportional to the vocabulary you have and the outputs being similar. So you're essentially trying to learn unity relative to a code book in the middle, the neural net representation of the weights. That actually represents that's the space within which you're actually mapping all the users. So essentially it's a non-linear variant of, say, SVD. Is what you're really doing there. So, and word-to-vec is coming out of Google, and the word embedding in general is a practice in NLP. We're looking at other variants now, but word-to-vec was great because it had the wherewithal to be out of the box and implementations that were fast enough, and then we could parlay this. So that's the representation.
Excuse me?
Yes?
So do you see any use for Spark streaming in your model?
Spark streaming?
Yeah.
I use Hadoop streaming. Spark streaming probably has some utility as well. I like Spark, I mean, Hadoop Spark streaming, same difference. I like it in that you can actually deploy and do things. I was going to talk about it in a minute, but I do some little tricky end runs that for our particular data and how I structure it that drastically can speed up the process relative to just a lightweight Python operator that's going through and doing special tricks on knowing what data is on disk. I probably shouldn't talk about that because it's definitely an end run, but it was way faster. But we try to do that because if I can speed things up, I certainly will relative to utilizing this at our disposal. This, again, what I'm trying to do here is show a survey that we, in fact, have tried, and the ones that really did well for us we're using. So cascading is another pipeline-based process. I'd say it's probably similar to Pachyderm in terms of what it's trying to achieve, and that is it has a model where you have sinks and sources, and you try to dictate how things go through there, shallow-based, and we've utilized that for our process of taking the user information and churning that through in a systematic fashion to construct our user characterization daily. And I won't go into much detail here, except to say that this was way easier to do and actually tremendously faster than when we originally did that churn in Hive. If you have to map stuff in SQL, it's really difficult. And this was a nice direct way to do that facilitated from our input to output a really strong process that allows us to do this in SLA in like 6 hours, whereas before it was like 12. So this is essentially the leading edge users that we see daily and their collected signatures aggregating this, what we call a user code or UU code, to then have those codes available for evaluation by our models for predicting whether you're demo or behavior and so forth. But Cascading being really nice, and there's the company Cascading, they were called Driven, and it's kind of nice relative to, they recently opened up to both Hadoop, Spark, and also Cascading, but debugging and kind of seeing behind the scenes, monitoring, seeing the processes, trying to optimize. It's been pretty interesting. They work very closely with us, and we were kind of early, so it was a bit spotty, but we're certainly using that more and more to try to understand our pipelines and optimize those as we see things cropping up. This is, I alluded to a moment ago, large-scale predictive modeling. This is where we have anywhere from 10 million to 100 million users going in there, and depending on what we care to predict on them, whether it be the demos, demographics, I should say, males 18 to 24, or whether they're apt to convert, or whether they're possibly fraudulent, all those kind of fit the same mold, and that is a gigantic amount of data goes in. We have characterizations of those users relative to truth that we've seen externally and can label those. And in general, it's usually supervised learning for the predictive modeling. And then we also do in very similar fashion unsupervised learning relative to simple centroids or k-means to get centroids that represent users that we can then compare in this signature space that we have. And again, this one's a process that's driven in combination of, well, mainly this EMR. EMR fires up things. We use some GPUs, instances, and fire those up, and again, parallelize that to evaluate modeling, and a similar process to evaluate users daily. I'm almost done here. And I just wanted to mention these folks that are great companies that we've worked with and had a lot of good interaction with. But Qbol is nice. They're a layer on top of Hive, where these are the guys who actually, when they were Facebook Road Hive, they went off and did Qbol, which has a lot of good facilities relative to a nice framework within which they're going to have queries, but they also do dynamic scaling so that they'll scale up and down a cluster as you're using that or not. We use them for our ETL and all the good things. Snowflake is a data warehouse that we've recently been using that is nicely and easily populated from S3, and we're using that to facilitate some of our fraud analysis. Spotinst is a company coming out of Israel, and their whole forte is essentially in the spot market at Amazon, effectively getting, they have a really tight interface with Amazon and can do a good job of predicting the cost of spot instance over time. So given that you can run an EMR cluster with core nodes and task nodes, they are dynamically swapping out task nodes at every hour increment if they believe that they can get less costly ones, and it's panning out pretty nicely for us. Plus they have a bit more robust provisioning on top of Amazon. They're very closely aligned with Amazon. And then Driven, I mentioned before, is a nice general, coming out of Cascading, but a general purpose tool for examining Hadoop flows and understanding bugs, hotspots, and allowing you to optimize those as well. So we've kind of had good experiences with all those. Plenty of other ones that we worked with didn't come in the frame and do very well, so they're not here. These are the winners. And finally, care about this, but we've been working for Hive for a while, so if anybody cares about these things, I've had good luck in working with some of these things and reducing the throughput on queries tremendously, especially the transfer function. In the context of Hive, where you can hop on your own thing as long as you fulfill the requirements of what is expected to come out. You can do a lot in there and then have that driven through the Hive and have awesome increases in throughput on that front. Plus, a little more systematic handling in Python for things that aren't necessarily done. And last slide, I believe. Yeah, last slide. Just kind of things we do. So I think I touched on this already. One I hadn't mentioned was the notion of cross-device, and that is in our ecosystem we have multi-screen. So typically we started focusing on sites and desktop, but certainly mobile, as you can imagine, is a huge space for us. But also as we're going more and more towards TV and integrating that, where TV is becoming more of a commodity that can be done on fly as well. We're integrating all those signals such that we can ideally know either at the household or user level, the same person, if it's on mobile, desktop, or TV, that we know it's either the same household or the same person, so that we can obviously limit the ads that a certain group sees, but more importantly, target them differentially so that if our clients want to hit them on TV, hit them a little bit on mobile, hit them a little bit on their desktop, we can do that and believe and understand that we know those users. Plus, obviously, it gives us a broader characterization of users. The nice thing about mobile, of course, is that whereas cookies can deteriorate daily, in general, your IDFA or Android IDs stay for a lot longer, and so that is a signature that is longer term, allows us a deeper characterization of users for longer, and anything that has continuity helps us to understand those users. By the way, I didn't say this, but these are anonymous users. I don't know who they are, and we don't have personal identifying information to see them, but these are entities that we pursue. So I'm not Big Brother, but we do know a lot about entities out there and try to target them. We don't know. Just to clarify there, we don't know people. And of course, detecting fraud, tons of bot activity out there. We work with third-party partners and we do our own stuff as well. Audience building. These are the kind of things that this huge bank of data that we collect daily and integrate with the truth signals and so forth is used to drive our industry. But we're always growing, and with that scale comes growing pains, and we're always looking for interesting solutions for that next generation, where we're going to be, end of this year, probably at 90 million auctions a year outside, given some of the international and so forth. So that's what I have to say. So I'll take questions, hopefully. Yes.
What's your strategy for tracking users across devices?
Well, the first order of business there is usually third parties have contractual relationships with bigger companies that kind of have a Rosetta Stone that allows them to unify. But our approach, if we had to do it ourselves, would certainly be relative to household, and that would be essentially IP address, user agent string, those things that occur in our ad calls that we see that can allow us to start believing that we have a small enough group of people and we think they're the same person, and then we see a mobile go on Wi-Fi and that unifies that there. We see the mobile go on Wi-Fi at work. So it's all about those circumstances which are not frequent enough from our perspective, but those circumstances that will allow us to see that there's a correlation between, say, a mobile signal and a desktop as a first pass. There's other things we could do, and most likely it would involve getting really deep on that would involve probably integration with third-party stuff. But to the degree we could do it, we could use user signatures that would characterize those users pretty well, and then go from there. But it's all about a seed or Rosetta Stone, something that allows you to get some semblance of a mapping between the two spaces. And then likewise with TV, we are getting TV data on a certain channel that allows us to have IP level information that at least at a household will start allowing us to see same users on TV, either the digital TV, whatever sort, Google TV, whatever, Apple TV, versus their activity on sites. Nielsen as a company does that kind of stuff as well. So there's lots of sources that allow us to start seeing that stuff at a certain level, and then we have to work hard to get it to be more granular relative to at least household targeting. So it's all over the data. And the quality of the data and how that data unifies things is what we're always looking for. So as Murtaza talked about, we do a lot of third-party integrations, and that typically is a rich bank of information. For example, right now, mobile apps, we're just bringing in some more data that allows us to understand not just that this app A zombie killers, but a blurb about that, where it's being sold, more meta information that we can then parlay into that space of user characterization and understand by virtue of the other words, the linguistic aspect of it, those words that describe an app, how other apps might be related above and beyond just same publisher or other things. So those things are what give a flavor to the users and allow us to do a better job of saying who in the space is alike, and more importantly, who, given that signal of downstream truth, is more apt to be like a person who does a click, and will hopefully do that click or conversion or whatever. That's end of the day, we're just looking for ways of being able to predict that stuff and unify that truth, or just characterize users as best we can. Any questions? Well, that's the wide world of tech advertising, ad tech.